Hi, in this video, we're going to have a look at finding the area bound between these two curves. This time we'll do it manually. Last video, we did it by using a graphics display calculator. So again, the 3 steps: visualize, number 2, points of intersection, number 3, integrate. Let's see how we go with the visualize step first. We're going to have to sketch it. So I'm going to label my functions here, 1 and 2. So the visualize step, we're going to have to work out some critical points. Whoops, could be helpful if I could spell, couldn't it? So what have we got? So for y equals x cubed minus 2x squared, I can see there's a common factor there, so I'm going to just factorize it. We have that equals x squared outside of x minus 2. Okay, so that gives me my zeros pretty easily, and it also gives me my y-intercept. Let x equal 0, then y equals 0. That's pretty trivial, isn't it? So that's the y-intercept. And let y equal 0, then we have x squared multiplied by x minus 2 equals 0. So x equals 0. The other thing I might point out here is that this is a squared 0, and so therefore you may or may not remember that this means that it bounces at that particular coordinate. Okay, so it doesn't cut through it, it bounces. So we've got a bounce, and then we've got a single 0 here, so it cuts through it to 0. Okay, so that's that one. The other one, so for y equals 2x cubed minus 3x, let's do the same sort of thing. There's a common factor of x there. So we've got 2x minus 3. But that's okay. We've got, therefore, oops, shouldn't say therefore. So let x equal 0. It's pretty trivial. Y equals 0. 0, 0. Let y equal 0. Then x equals 0. 0, 0. Or 2x minus 3 equals 0. That's a bit more yucky, but we can do that. That would be 3 on 2, comma 0. So that's really quick. I'm sort of almost, without the talking, I'm emulating exactly what it would be like, under test preparation, whatever else. I'm just doing a rough and ready, sort of like just going straight for the basics without writing a very solid solution out. Okay, so now in slide 4 here, let's put it all together. Just looking at my values here, I've got a 2 as an x coordinate. I've got y. Okay, so I just draw in my my axes. It all seems to be in the positive quadrants by the looks of it. So let's just draw in blue, maybe. What have we got? We've got a 0 here at 2, and we've kind of got a bounce at a bounce at 0, and then it cutting through at 2. Now it's a cubic. It's got x squared minus 2x. So as x is getting really big and negative, x cubed minus 2x will be really negative. So it's gonna start here and end here. Just using the dominant term sort of approach. And so I'm gonna have something like that. Okay, so that's number 1. I might just change to red just for the second one, and we've got it's a cubic as well. So we've got, let's see now. I think I might have made a mistake in this one, have I? Yeah, I did make a little bit of a mistake, only just here and here. I do apologize for that. Rather than redoing the entire video, I think I might just make the change. It was supposed to be 2x squared minus 3x, and that would give me the rest of it as I've got here, really. Sorry about that. So we've got a quadratic. It's going to be a smiley face quadratic because a is positive, so it's going to be like this. And we have, let's see now, we have an x-intercept at 0, x and y-intercept at 0, and then we have another one at 1.5, so that's going to be roughly there. And so I'm going to have something along the lines of, sorry, try that again, like so. Okay, more or less, that's what it's going to look like. Okay, so that's our graph so far. Okay, so far, so good. And it looks like we've basically got a region here with 2 points of intersection, like so. So let's confirm that. That's our visualization. Let's confirm that by working out those points of intersection. I'll need to go to the next slide for that. So basically, points of intersection will be found when I set this equation equal to this equation. Because it's y equals this and y equals this, I can basically set each of the right-hand sides equal to each other. So I get x cubed minus 2x squared. I'm going to flick between screens quickly to get this down. So x cubed minus 2x squared. Stick to black, sorry. Is equal to 2x squared minus 3x. 2x squared minus 3x. So again, x cubed minus 2x squared equals 2x squared minus 3x. Okay, so let's put all this onto one side of the equation. So we're going to have x cubed, and I'm going to subtract 2x from both sides. That's minus 4x squared. I'm going to add 3x to both sides. That's plus 3x, and that leaves me with nothing on the right-hand side. So we've got x cubed minus 4x squared plus 3x. I'm going to take out a common factor of x. That leaves me with x squared minus 4x plus 3 is equal to 0. This is a quadratic that needs to be factorized. If your factorization skills are weak, it's not going to be easy for you to do this in your head, but you can use box method or whatever other method you want to. But I can see that minus 3 times minus 1 is equal to positive 3, and minus 3 plus negative 1 equals negative 4. So it's going to be x minus 3, x minus 1 is equal to 0. Okay, so that means I've got x equals 0, x equals 3, and x equals 1. I've got 3 x coordinates, not 2. So wait a minute, let's have a look at that graph again. So 3 points of intersection, and yet here I've only got 2, here and here. So what I have failed to do is to draw my graph in a way which captures that third quadrant. If you have a look at it, I've made this way too steep and this not steep enough. So there's no need to redraw it at this stage, but just for the sake of it, I'm saying that this is probably needed to go up like that. This probably needed to be shallower to be like that. And there's probably a value up here somewhere where there's a point of intersection. Okay, so I haven't quite captured that. The visualization's given me what I need. I don't need to go back and redraw it, but just be mindful of that. You know, trust your analysis, check your analysis against your graphs, try and determine why there'd be a discrepancy, and then move on from there. Importantly, though, I know that I've stuffed this up, but I can see that I've got one region here, and there will be one region here. This region will be blue over red, and this region here will be red over blue. Okay, so again, if I just go, so the first one is blue over red. Okay, so between 0 and 1, I might just put these into numerical order so it makes more sense what I'm doing here. So between 0 and 1, I've got the quadratic on top. Again, I'll just show you the graph. Sorry, not the quadratic, the cubic is on top. So the cubic is on top of the quadratic. So that means that this one is on top. It's just an aid to my memory more than anything else. And between 1 and 3, I've got the quadratic on top. And so that would be y equals 2x squared minus 3x. Okay, so that just keeps me honest, so I know what I'm doing. The graph on top is what is subtracted from. Okay, I think we're cooking with gas now. The third part is the integrate. And I'm going to work out the integral of each part in turn. I've got the area of the integral between 0 and 1 of x cubed minus 2x squared minus 2x squared minus 3x makes plus 3x. So that's blue minus red with respect to x plus the integral from 1 to 3 of, now we're going to reverse it. So it's going to be 2x squared minus 3x minus x cubed minus 2x squared is plus 2x squared with respect to x. I'm just going to simplify that out. So it's the integral between 0 and 1 of x cubed minus 4x squared plus 3x with respect to x plus the integral between 1 and 3 of, I might do them in power order, so minus x cubed plus 4x squared minus 3x with respect to x. And now I just need to integrate it. It's just using the power rule, so that's not too bad. So that's equal to, let me see now, x cubed will be x to the power of 4, and then I'll put a quarter on the outside, minus 4 multiplied by a third x cubed, plus 3 multiplied by a half x squared. And that's between 0 and 1, plus minus a quarter x to the power of 4 plus 4 multiplied by a third x to the cube minus 3 multiplied by a half x squared, and that's between 3 and 1. Okay, simplifying that a little bit. Nah, let's just go straight for substitution. So having a look at that first integral there between 1 and 0, we are going to have a quarter 1 to the power of 4 minus 4 times a third. That's just 4 thirds, right? So I'm going to say 4 thirds 1 cubed plus 3 times a half is 3 over 2. So I'm going to have 3 over 2 1 squared. And then I'm going to subtract from that, fundamental theorem of calculus, I'm going to subtract from that this thing with a 0 here. That'll zero out everything. So there's no point doing that. That's as far as we need to go. Plus, and now this is the bit that needs to be looked at more carefully. We've got minus a quarter. So minus a quarter multiplied by 3 to the power of 4. And then we've got 4 times the third, which is 4 over 3. So it's plus 4 over 3, 3 cubed, minus 3 times a half is 3 over 2, 3 squared, minus, again, it's up to you. You can either do this in one step or two. I will live life on the wild side and do it in one step. I'm subtracting negative a quarter. So I'm going to add a quarter multiplied by 1 to the power of 4. I'm subtracting 4 thirds x cubed. So minus 4 thirds 1 cubed I'm subtracting negative 3 times a half x squared, so that'll be plus 3 halves 1 squared. Wow. Just a lot of numerical calculations, really. To be honest, I took this question from the textbook. It's a calculator question, which I thought looked fairly simple to do without a calculator. And it is fairly simple, but you can see why it's a calculator question. It's more onerous than complex. Let's have a go at simplifying all of this stuff. So a quarter times 1 to the power of 4 is just a quarter. Minus 4/3, 1 to the power of 3. Plus 3 halves times 1 squared is just 3 halves. So there's a whole bunch of fractions there. Plus minus a quarter. So that's just going to be minus a quarter multiplied by 3 to the power of 4. Well, 3 to the power of 4 is 3 squared is 9. So 3 to the power of 4 is going to be 81, right? 3 squared times 3 squared. So it's going to be 81 over 4. And then 3 cubed is 27. 3 squared is 9. 3 is 27. And then we're going to multiply it by, we're going to cancel out one of the 3's to start with. I didn't see that. So a 3 will cancel out here, leaving me with 3 squared. So what 3 squared is 9. And so we're going to have 9 times 4, which is 36. That's nice and simple. So we're adding 36 minus 3 halves times 3 squared. So that's going to be 3 times 3 squared, which is 3 cubed, which is 27. So that's going to be minus 27 over 2. And then the rest of it's a bit easier because it's just to the power of 1. So it's going to be plus a quarter minus 4 over 3 plus 3 over 2. Wow. Okay. Let's maybe just have a look at the common denominators first and collect those. So I've got a quarter minus 81 quarters is 80 quarters. So negative 80 quarters. Plus 1 is negative 79 quarters. So that's all the quarters done. And then I've got my thirds to have a look at now. So I've got minus 4/3. Minus 4/3 is minus 8/3. And I've got 3 halves. Minus 27 is going to be negative 24 halves. Minus 24 plus 3 halves is going to be minus 21 halves. And I think that just leaves me with my 36 there at the end, like so. So, look, rather than waste too much more time on this video, hopefully you can see what to do from here very briefly. I could find a common factor here of a common denominator of what, 12. So multiply that by 3, multiply that by 4, multiply that by 6, multiply that by 12. That'll get me a common denominator and I can figure it out from there. Alternatively, I could turn them all into mixed numbers and then add them up from there instead. Either way will get you an area that you're looking for. But that's hopefully fairly trivial from there, just tedious to watch me figure out common denominators and stuff as a consequence. So I'll leave the video here. Hopefully that makes sense to you. In the textbook, it only has a calculator-based question around these sorts of things. So I wanted you to see that it is possible and very doable to solve this longhand if necessary. Thanks for watching.